Hi, Nikhil. How are
Hi,
you?
Mala. How are you?
Um, Enjoying the conference. Thank you so much for accepting our invitation to speak. It's a pleasure to have you present with us today.
Likewise, the pleasure is all mine, and it's been fantastic. I've been attending the sessions and like kick off with Dawn and like the fleet presentation, and I'm here now. I'm super excited, pumped, ready to go. It's early morning out in Seattle out here. It's 7 a.m. So I was up at like 5, starting with the first presentation. So super excited and pumped to be here.
That's great. Let me quickly introduce Nikhil. Nikhil works as a principal engineer with Amazon. So, Nikhil, do you get to see James Gosling often because he also works with Amazon?
I haven't seen him yet. He works in AWS. I'm on the ad side of Amazon, but hopefully, one of these days, I should actually ping him on Slack.
That's a great idea. So Nikhil is a pop. Let me continue with the rest of the introduction. Nikhil is a popular speaker and he hosts interesting workshops on various topics, including robotics. A Java champion, he has also contributed to multiple books. Also, Nikhil likes gardening. So this is something that you will not find on his official resume. So Nikhil, which vegetables did you grow recently or you like growing?
So this year it was actually an exceptionally dry, summer out in Seattle. So this year's harvest is like we got tomatoes, we got bell peppers or capsicum, then some Thai chilies, basil, and we planted some stuff for the winter. So pretty excited for that.
That's great. You also mentioned that you love to hike.
Yeah.
Any recent hikes that you might want to mention?
Just last weekend, we went basically to the North Cascades and also to Rainier, so sort of like the north and the south we covered. And like Don said at the in his presentation, like self care and um, having a hobby and everything is like important. So gardening is like one of my hobbies where I end up spending
Yes.
some part of the morning in that, like at least half an hour, 45 minutes, and then weekends at least one hike or something like that. It kind of helps me be like physically active and motivated and work towards some fitness as well. So
That's super interesting. I think I can talk with you for another hour like this, but I am
yeah.
not going to do that. Let me add your screen to the stream and have fun with your presentation.
Thanks a lot, Mala. Appreciate you introducing and sort of kicking it off, breaking the ice. And believe it or not, I'm presenting after such a long time. So it was good to present at like with like friends and the sort of the Java ecosystem family. So what we're going to talk about today is, should I upgrade my Java, basically? Should I upgrade to JDK 17 right now, but this can be extended as new versions of Java go on releasing. So with that, there is a lot of content today, so we'll be waiting for the questions towards the end, but we'll do like a quick introduction. I think Mala did a fantastic job about introducing me, but I'll just reiterate some of the things. Then we're going to dive right into the performance comparisons, then do some sort of feature analysis of like what newly was added from 8 to 11 to 17. I'm not considering the preview versions of those, like only the DGA versions. And along with addition of the features, there were some removals as well. So we are going to look at the removals as well. And then if time permits, we'll take a look at all the garbage collectors that we have available currently in Java, and then summarize and then open up for some questions. So let's dive right in. As introduction, as Don mentioned, as well as Mala mentioned, I'm one of the active project leads of Eclipse Collections. I'm also a Java champion. I can be reached out to on Twitter. My Twitter handle is Nikhil Naniwade. And generally, I tweet more about just hiking and like all the just non-technology stuff. And sometimes I sprinkle around Java related stuff as well. All the code that you see here, as well as the slides, are available on GitHub. The link should be available later on as well, but essentially it's should I upgrade my Java, like the question that we are trying to answer here. I would like to extend a special thanks to my friends Billy Corando and Chandra Guntur, who helped me with the content to actually, like, not just the review part of it, but even actually helping me with the real content. So with that, let's look at what JMH tests are. So JMH stands for Java Micro Benchmark Harness. Essentially, it's our way of benchmarking our application or our code, and ensuring like how it works from a performance perspective. Now, I just want to like sort of like throw caution out there, like the numbers that you see as well as the code that you see, it should not be considered as authoritative. And the reason why it should not be considered as authoritative is when you look at the benchmarks, like there are some reasoning behind actually writing the benchmark in that way. However, they are fairly naive. They're fairly like trivial pieces of code. So your the way your application behaves for your environment is definitely going to be different. So your mileage may vary. You have, please test, benchmark, and profile your own application, and make sure that you test against that. The way this was measured is I used my teeny tiny Intel i5 4-core laptop that was there, and ran 3 forks with 5 warm-up iterations and 5 measurement iterations. All the measures are reported as operations per second. So essentially, bigger the numbers, the better the performance. So with that, let me explain how was the measurement pattern. So essentially, I was thinking quite a bit about like writing some benchmarks. I wrote a few benchmarks, realized that like most of them like came out to be like very difficult to like sort of justify or even understand the reasoning behind why the numbers were looking what they were. So then I like sort of inspected some of the code that I had written in the recent past, and realized that like, hey, I seem to be doing like map.get as well as map.put operations quite a lot of times. And then there was some like if else logic as well as like some equals logic sprinkled around that. So I decided to like just use that in the benchmark, and essentially measure for string and integer, not for any other objects. So let's first look at how map.put looks. So the code is again very simple. I have an array list of elements for a particular size. I iterate over all the elements, and then go on calling put on this hash map, which is the JDK integer, and then I just put each. For string, I end up caching the value of the string by just extracting it out, and then do the put. So like I said before, it's fairly trivial, it's fairly naive. So think about these numbers as just indicative, not authoritative. Uh, so how do the numbers actually look like? Like I said, to begin with, higher numbers are better. So bigger numbers are the performance is better. And I have bolded, the sort of the good ones, or the better performant ones. So you can see JDK 17 consistently performs better for map.put for integer across like 8 and 11. And it's just not like teeny tiny bit of better performance. I think it's significant enough a better performance for you to consider the the performance benefits that you will get with JDK 17. uh, However, when it comes to map.put for string, the the case changes slightly. Here you can see for lower sizes, JDK 11 is slightly better performant, and I'm going to say very slightly, not like significantly, like it was in the case of integer with JDK 17, which was significantly better performing for integers. Over here, JDK 11 is slightly better performing. However, I think I want to attribute this towards like just the test setup, or some like specific to the environment conditions or something like that. And I need to dive deep and understand the reasoning behind it, and I'm just going to attribute this to like just some like I would call it like manual error or human error over there. But as you can see the trends, right, like if you just see JDK 8 versus JDK 17, the trend is that like you're getting better performance with 17, because higher numbers are better. And then it's sort of no questions asked for like the higher size of the array list or of the elements. JDK17 is better performing anyways. So now with that, let's look at how the tests look for map.get. So essentially similar to how it was for map.put, but in this case, I decided to do something like, interesting, where in the add before class, I end up pre-populating the hash map, and I populate it with the key to be each and the value to be the negation of each. And why, like, literally no reason for it, just because. Um, and then I do some equality over here and throw an exception if they are not equal. Similarly, in case of string, I do the same thing, but here you will see that I'm actually calling the string dot value of twice, instead of, like, because I cannot cache it because it's the negation. So with that, let's actually look at how it essentially performs. So in terms of performance, it's kind of in line with how it was for map.put for integer. JDK17 is consistently better performing than 8 and 11. I see that there's sort of an outlier at 25,000 elements, but I'm going to just attribute that to be outlier and something related specifically to my setup. But again, you can see the trend. The trend is always like, you're getting better performance as you're using new versions of Java, new versions of JDK. And like I said before, all the data is in operations per second. It's for throughput, and higher the numbers, the better they are. Now let's look at the map.test, map.get test for string. Here again, similar to how what we observed in map.put, the same trend kind of continues, where JDK11 seems to be better performing slightly for up to 25,000 size elements. And again, I need to dive deep to actually figure out where the bottleneck is, whether, like, I've like discovered something, which I highly doubt, or whether it's just something to do with my benchmarks, and, like, iterate and improve about it. A few things to note about, like, writing and running benchmarks, like actually running them. It's not a trivial exercise. It is extremely time consuming. So you're always, like, and when I say, like, time consuming, as in it's like literally calendar time consuming, because it's always trial and error. Like, you have to, like, run, if you run too few iterations, your, like, results can change. But if you run, like, too many iterations, then your results will eventually stabilize, but it also takes time to, like, run those results. So it's sort of like a multi, like, day or multi-week effort for getting some authoritative numbers. And that's the reason why I said that think about these numbers as indicative. It is sort of showing the trend that as you upgrade, you get better performance. But again, for your own application, you should write your own benchmarks, or at least some performance test or the other, to make sure that you're not uh, retrogressing, and you're not essentially, like, going down a different trend, because sometimes that might also happen, and it might mean that, like, hey, maybe there's a bug somewhere in your code or in some library code, and that can help you isolate it, and then eventually either fix it, or upgrade your library, or do something about it. But always just think up, like, always keep performance at the back of your mind. And that's the reason why I actually started my presentation out with performance, because most of the times we see the numbers towards the end, and then, like, we kind of lose focus by then. So with that, let's look at memory tests, because along with the throughput, there's also the memory component for our software, right? Because again, even like memory is not free. So whenever our programs are running, they have to use the heap. And the way memory tests are sort of, like, interpreted is, the smaller the numbers, the better, because you want less memory to be used by your program. So again, similar to JMS test, I was again encountered, like, hey, how do I write a memory test? Like, I even, like, tried to investigate some of the tools that are available in open source, and then inspected the actual data structure sizes that are there, but then realized the tests were inconclusive, because the the list, set, and map, like, the actual object sizes are the same. So I sort of, like, thought about it a little bit, and understood that, like, hey, the memory is like sort of more impactful when you have like the long running programs, so to say, or rather it's more observable when you have like a long running program like a web server or something like that. So what I did was I basically just created a trivial program which loops 5 times and then measured the memory out of after each iteration. And essentially only for the sake of representation, the memory after the fifth iteration is reported. And that's super important because like I could see that there were some trends in between, but like it becomes sort of too many numbers to digest in a presentation. So that's why I'm only reporting the fifth iteration. All the numbers and the code is available on the GitHub repo if you want to like for like if you just want to peruse it like afterwards. So now with that, how have I measured the memory? I've used that trusty runtime methods, and then essentially use memory is equal to total memory minus free memory. I mean, that's easy math, simple math, right? So I'm just doing that, like, again, extremely naive, extremely trivial. The smaller numbers are better. I've again used my same 4-core i5 laptop, and same disclaimer as JMH test, your mileage may vary. Please make sure you test, benchmark, and profile your application because things change application to application. With that, how does the code look? Like I said, it's extremely trivial. It's extremely naive. All I have is a for loop which will iterate like 5 times, and I'm populating essentially 3 data structures, a map, list, and set, and then based on the size, I end up just populating it. And just for the sake of representation, uh, you know, I'm only quoting the fifth the measurements after the fifth iteration. Now, inside the method print memory utilization using runtime, essentially I am invoking system.gc and pausing for a second like 3 times. And that's just because like, I want to make sure that I'm giving an indication to the JVM to garbage collect. But like the doc said, just because I call that doesn't necessarily mean garbage collection will be invoked. It's sort of an indication to the JVM that like, hey, please invoke. And then just so that I don't measure immediately, I like, pause for a second or something before measurement. Again, all of this code is available on GitHub already. So let's look at how the numbers look. So interestingly, basically the from 10 to a million, you can see that JDK 17 pretty much consistently outperforms 8 and 11. And I'm saying outperforms because it remember, smaller numbers are better in case of memory usage. So all the numbers are given in kilobytes, and except for a million, which is like where JDK 11 like I like has a tad better performance than 17, which I am just going to attribute to like it being an outlier or something related to the test and the naiveness of the test that it was. That's the reason why I'm just going to think about that as an outlier. So you can see that consistently JDK 17 is performing much better than 8 or 8 and 11. So again, just to summarize, we saw that like in the JMH test, Java 17 consistently performed better than 8 and 11 for map.put and map.get in case of the integer. For map.put and map.get for string, 17 consistently performed better at large sizes. For smaller sizes, I think there was like some other error or something going on, which I need to dive deep about that. Java 17 consistently used less memory. So thereby we can at least conclude that like once you upgrade to 17, you're going to see some performance gains. Again, disclaimer, standard disclaimer, your mileage may vary. Please test, benchmark, and profile your application. Now, it's not just performance improvements that you got or that you get when you upgrade your versions of Java. In addition to that, you also get feature improvements because new features were added along the years or along the releases of the JDK versions. So the very first one, and some folks will say that like, hey, why are you even covering like VAR? It was part of like JDK 10. It's like forever ago. But it's kind of like my warm-up exercise, that like, hey, it's something that everyone is familiar with. So that's why like, but if you're still on 8, you're not getting the benefit of var. Only if you're on 11, you're getting the benefit of var. So what does var stand for? Var is nothing but a local variable type inference. It's the idea that you let the compiler figure out the static types, and it's just so that for your convenience, as when I say yours, as in it's just for the developer's convenience, so that they don't have to type it. And var can only be used for local variables. Remember that. And these variables need to be explicitly initialized. All right, so let's look at some code, because seeing is believing. I always believe that. So in case of, like, let's say you just have a map of integer and a string, and you have initialized it with the proper data types and everything, with the proper values. So with that, you can just replace the left hand side over here, this type declaration, with just var. So this is where, like, it's like creating more like terse code and much more compact code. However, there are a few, like, caveats while you're using var. It cannot be initialized to null. So you can't do var with var equal to null. Var cannot be used to assign lambda expression. So you basically cannot do var, like, with var lambda equal to, and then, like, a lambda something. Uh, and this is my personal recommendation, and I think I saw some blogs as well while I was researching for this, like, give similar recommendations that please avoid var with polymorphic code. And the reason for that is it just becomes sort of a maintenance nightmare, as well as, like, you sort of can open yourself up for runtime issues. And always, like, runtime exceptions are kind of difficult to catch, like, because I always prefer compiler errors versus runtime exceptions. And essentially, with polymorphic code, it can lead to, like, some weirdness, especially because, let's say, you have an animal, dog, cat, and then you just initialize it to, like, one type, and then down the line you're reassigning or something like that. It can lead to, like, some weirdness, because essentially, in my opinion and in my experience, var doesn't play nicely with polymorphic code, and I generally avoid using it. With that, next one is some of, like, one of my favorite features. Like, it's the updated switch statements, or the expressions, which were introduced in JDK 14. Prior to JDK 14, you just had switch statements, which were basically like a wall of text, like, covering all the conditions and everything. But starting JDK 14, you can actually use a switch statement, or what we call it as switch expression, to yield a value, essentially to, like, give a value back. A case statement can also contain multiple values separated by commas, and this makes our life as developers, like, really really awesome, because you have to type, like, less code. And we'll see the example in a second. Like, with the introduction of the updated switch statements, or expressions, as we want to call it, a new restricted identifier. A restricted identifier is similar to, like, var, what we saw right now. Yield was introduced. It is specifically kind of introduced to be used for code blocks, and we'll look at that in a second as well. A few more additions and updates that happened was, now switch can be used on enums, and that makes it even much more. That makes it easier to write, like, maintainable code as well. A few caveats. Switch expressions need to be exhaustive. We are going to see what exhaustiveness means in a second. And switch expressions must yield, as in, like, they must give a value, or throw an exception, because an expression at the end of the day needs a value. It needs, like, attached to a value. So with that, let's look at how it was before JDK 14. And I have purposely kept this, like, big wall of text that I have to keep on scrolling. It's because you can see, all I'm trying to do is I get a month number, and I'm trying to determine which quarter it is. So 1 2 3 will be Q1, 4 5 6 will be Q2, 7 8 9 will be Q3, and likewise 10 11 12 will be Q4. But you can see that I had to write each case for each of the quarters, even though most of them were redundant. And then all I'm doing is returning Q3. If it was sort of a switch statement, then generally you will have a string quarter equal to, initialize it to something, and then you will have, like, a break statement. Again, break statements make it sort of a difficult thing to maintain, because, let's say, sometimes you forget a break statement or something like that. Your test cases don't catch it, and the way switch case works is, if unless like, if a particular case is evaluated to be true, and you don't have a break in it, the the code evaluation will keep on going. With switch expression, we get some safety nets. What happens is now you can actually do like Tor's syntax like this. So since 1, 2, 3 were redundant, like basically they were yielding the same value of Q1, now you do 1, 2, 3, and then you can use the updated syntax, which is similar to a lambda, a dash, and an arrow instead of like colons as it was in the previous case. 4, 5, 6 is Q2, 7, 8, 9 Q3. So essentially we have just compacted like that big wall of text into like just 5 lines of code. Now you will see there is a default over here. That's because switch expressions need to be exhaustive. And we'll look at what exhaustive means in a second. It's very important. I'm going to keep on iterating about exhaustiveness over and over again. There are a few advantages that you get by having switch expressions. Is now you're actually able to do like something like this, where you can have final string quarter and you can assign, and that sort of makes it much more like interesting and much more flexible. It gives you much more flexibility when it comes to switch statements. And now the yield syntax, and the yield syntax is pretty cool, where previously, as you saw in the previous slide, you just had a lambda and you were returning a value or yielding a value. But in this case, let's say you have a code block because you either need to do some processing or you need to like log something or something like that. You can have a code block like this. And yield is something. Yield is the identifier that you'll use with code blocks. And in this case, 10, 11, 12, it stands for Q4. Yeah, last quarter, new year is coming close. And believe it or not, the Q4 is going to start in a couple of days. So that's pretty cool. And essentially, you can see that like I am yielding the value out there as Q4. Okay. Now, lastly, in terms of the updated switch statements, I want to discuss switch with enums. So just for example's sake, I ended up creating like, all the 12 months as an enum, and instead of just passing a month number, now I'm passing an enum. So if you will see, I'm doing like, the same, again, the logic remains the same, but now instead of the number, it's the enum, where it is like, Jan, Feb, March yields Q1, Q2, Q3, Q4, likewise. You will notice that there is no default statement over there. That's because now the compiler can actually figure out that like, hey, it's an enum. Enum has all of these values, and I need to only cover, the developer only needs to cover those values. And that way, the switch case statement or switch case expression essentially becomes exhaustive. So you don't need the default case anymore. And that sort of helps you write maintainable code as well as much more extendable code. The reason for that is like, imagine you just had a default statement, and I know like there are no 13 months or like 14 months, but let's imagine that something happened and we just got like a new month, or like some in your use case, like your enum got a new value, right? Now if you had default, you as a developer would always had to remember to go back and fix that particular condition in case of the enum, because the default would like it would just default, the new value would just default to that. But now you get compile safety, because the moment you add a new value in that enum, the compiler is going to figure out that like, hey, it's no longer exhaustive, you need to handle that case. So that gives you an added layer of protection. So in my opinion, that's pretty cool. It makes it much more safer. And then down the line, when we get like pattern matching for switch as well, it will be extremely beneficial when all the new features sort of like combine with each other, and they like play in harmony, and then you get like a nice cohesive feature set. And what I mean by that is like we'll see in a second. So with that, like another of my favorite features was text blocks. It was introduced in JDK 15. Now prior to JDK 15, I mean, I still remember this like very recently writing, when we had to write like long strings, like even like JSONs or something like that. It was extremely unmaintainable, because you had to take care of the concatenations, you have to take care of the delimiters, you have to take care of the escaping, like a lot of things. And it was like, though that was just like the triviality of it did not make any sense. Like it wasn't the challenge that like you had to write, you have to figure out like some new code, but the challenge was like you have to figure out like how do you escape something. So with text blocks, once text blocks were introduced, they essentially minimize the Java syntax that is required for a string. And remember, text blocks are nothing but an alternate representation of a string. So all the rules and all the characteristics that apply for java.lang.string, the same ones apply for text blocks. It's an effort, and trust me, it does improve the readability and clarity of code. Uh, and I've put a link out there. There's a very nice blog, programmer's guide to text blocks. Please take a look at that, and it sort of shows all the different scenarios. Now with that, let's actually look how it was before JDK 15, before text blocks were there. And I've purposely, in the title I have like the long string, because really just imagine, how many times you have dealt with like these long JSONs. In this case, there are just four elements in my JSON, but still there is a ton of things that are going on there, where you have the /n, then you have to escape the double quotes, you have to remember the plus sign, you have to remember the comma, and then the /n, blah blah blah, right? IntelliJ actually makes it. I'm a big fan of IntelliJ, as you can tell. I'm even presenting from IntelliJ, actually, believe it or not. The what one of the features that was given was you could inject like a language or a code fragment, and then you could edit that fragment based on that language. So that's what I always used to do, prior to Java 15, when text blocks were introduced, where I would have to inject like that JSON, and then I would just use IntelliJ's JSON fragment editor to write the JSON to make it easy for me. But again, you don't have to really do that anymore, because you have text blocks, and look how clean it is. You start the text block by denoting it with 3 double quotes, and you end it with 3 double quotes, and everything that goes between them is kind of preserved as is. So like the /ns, or like the new lines, they preserve the double quotes, they are preserved, and that way you don't have to worry about the escaping and everything, right? Now, but this works very well for static strings. So the next question will be, but hey Nikhil, what if this Nikhil is a variable? These are variables, these are not what if it's a variable and these are not static? What can you do? So there is an option, because you can essentially use the formatted uh, you know method on it by putting in placeholders in the text block. Like for example here, %s, %s, and %d, these are the placeholders. And by using .formatted, you can essentially parameterize these values that are there, and pass in the actual values that you require, and then those will be substituted. And right now I've just put in Nikhil and Seattle and 1 2 3, but those can just be variables as well. So that's why it makes it much more easier and maintainable, because you can kind of correlate where what is, and it basically makes handling strings much more easier and clearer. um, with that, I want to get on to my next kind of a favorite addition as well, or improvement. It's called helpful null pointer exceptions. And essentially, prior to Java 14, it was extremely difficult to isolate null pointer exceptions in chain method calls. I mean, I still remember one of the first times when I started coding, and I got the NP, and it was actually in an integrated environment, and it was based on some input, like having a null or something like that, and forgotten that null check, because there's always that one null check that you end up forgetting, and that comes to bite you. But essentially, I had forgotten that, and it was kind of difficult for me to isolate. I wish I had this back then to actually help me out. But essentially, prior to 14, that was the case, where you had to play the investigator role to find out within the chain method calls what essentially was throwing the NPE, and what was causing it to throw the NPE. From Java 14 onwards, the null pointer exception actually prints out a very helpful and a detailed message, which tells you the location and cause of the NPE. And I have to give you a caveat that in Java 14, this was behind sort of a flag that you had to enable. From Java 15 onwards, it's by default, these are turned on. The helpful null pointer exceptions are turned on. Another caveat is that only when the JVM throws the NPE, it writes the what do you say, the detailed helpful message. However, if let's say you have thrown the null pointer explicitly, then in that case, it doesn't print that detail helpful message, but rather the message that you have given. So with that, let's look at how it was before. The old style was essentially, just imagine you have a person object, first name, last name, and in this case an address, and you have this chain method calls get address, get city to lowercase. It would just print saying that it's an exception. You did not know, you just knew this line, and then you had to you had to sleuth your way around to figure out what exactly was null. Now in this case, it's very easy because you have the declaration right out there. But imagine this running in a web server code or something like that. Sorry, in a web service where you're actually getting an input and then you're trying to decipher, and you have not logged it, or you have a ton of log and you can't figure that out. So now with the helpful null pointer new style, what ends up happening is you actually get the reason and the location of the null pointer. For example, in this case, it shows that the null pointer is thrown here, over here, you see here. And then it also shows the reason for it, that hey, address is null. So if you see here, the address is null. Now that makes it so much more easier for you to isolate and then debug and figure out what the actual issue is, versus trying to sleuth your way around and keep on guessing and logging multiple things. And then to sort of extend the same example, let's say now you had an address, but the city was null in this case, right? In that case, it will show that hey, the string dot to lowercase, basically the null pointer is thrown here, and that is because the address dot city, so the city is null. So it's quite interesting, it's quite important, and it's, in my opinion, it's pretty cool and helpful for developers, especially when it comes to debugging issues out in integrated environments. A few things that I want to mention out here is, as you can see, with the helpful null pointer exceptions as well, you get to start seeing the variable names, or the method names, and all of those. So in case you have some sensitive method names, that can make you susceptible to some vulnerabilities or something like that, just be cautious about it, because they, let's say your logs are available in the public domain, which I hope they are not, or at least they're behind some entitlement or something like that. My point is that it might happen that you will inadvertently end up exposing stuff. So please make sure that your variable names and everything are aptly named, and that makes it much more helpful. With that, and let's go on to the pattern matching. For instance of, so essentially, this was introduced in JDK 16. What used to happen pre JDK 16 was, you would end up having a bunch of if statements, and the way the code was handled, it would be handled based on a particular type of the object, and then you had to cast and everything. And I'll show the code in a second, which will make it much more understandable. However, that was quite error prone, because casting is error prone. It becomes difficult to maintain. It basically becomes a maintenance nightmare, and it has numerous other drawbacks, right? And already many languages like Haskell, C Sharp, etc., already support this for its safety as well as brevity. So this was Java's way of basically kind of uh, adopting that same pattern, if I may say, in order to help us developers. So let's look at how it was. In the old way, let's say you have you have an input object, and if it was an instance of a string, then you're going to do something. Let's say in this case, I'm just taking it as a string and then returning after the concatenated string. Now the interesting part over here is, here you have to do the casting, and then it's basically just a lot of redundant and repeated code that is there. Now similarly, the same thing for integer, same thing for double. Now let's say you had many more, you would have to basically have those lines repeated over and over and over again. And all casting, one of the reasons why it becomes it's so error prone is, while writing code, generally I would end up just copy pasting. And then let's say you do a change and you change it to an instance of, let's say for example, a long, but you forget to change it over here, or vice versa, then you will get a a cast class exception, and that is sort of, you want to avoid that. Now whereas in the new style, with the introduction of the sort of the pattern matching, for instance of what happens is you get more terseness. because previously where you had like string equal to the cast of a string and then input object, you have the ability to just do that inside the if statement. So what happens is, if the input is an instance of a string, you're giving the variable name right there. So what will happen is, Java will end up assigning a string, this variable, to the value input, and a string will be of type string. And interestingly, similar to the previous way, the scope remains within this block. So it is basically your variables are scoped within the flow. Okay, now what is happening with pattern matching out here is Java is helping us sort of decide the flow of our of our code based on the shape of the object. Like in this case, like think about it this way: you have the shape of a string, and then this is your mold, and Java is just helping you match the shape to the mold. And that's pretty much what pattern matching is. And it's pretty cool. And that's down the line we're going to get pattern matching and the updated switch statements together, and then that's going to make it much more easier for us to write even the switch case code. Um, with that, let's move on to records. Records were introduced in JDK 16. It was an effort, and I would say it was a successful effort to uh, provide the ability to model data using classes or using objects. So essentially, when I look at some of the code that I have written, you end up having sort of these classes which are only data holders, and they end up using they're just used to transport data from A to B. Now with records, it ends up giving you the ability to model the data using classes and objects. Now prior to records, we as developers had to write like what we call as pojos, and all the boilerplate that came with it, like essentially the constructors, the accessors, the hash code, toString, equals, so on and so forth. With records, you get essentially all the fields that are in the record become private final. They're shallow immutable. We can discuss about what shallow immutability means separately, but essentially these are private final. You cannot declare instance field in records, and then you actually get a default implementation for all the accessors. For your member variables, as well as the hash code, the toString, and equals. They get automatically generated. However, if you have some specific need and you want to override your default implementations, you can always do that. You can also write custom method definitions inside records. There is a pretty nice block called as data-oriented programming in Java, which kind of covers records and all the other stuff that we discussed right now succinctly, and I would highly advise you to read that. So let me speed up a little bit. In the old style, you just had this pojo, you had private final string and member variables, and then I didn't even bother writing the constructor and everything, because generally like I would just code generate it on in IntelliJ. But for the new style of records, you essentially get the ability of defining your member variables right in the record definition, and then you get a constructor created, like it's the default implementation of the constructor generated for you, and Java does it by default, as well as if you want to introduce new methods, you can do that within that record itself. And then let's say you want to override like specific default implementations, you can do that as well. So in this case, I didn't want it to be person record, I just wanted to return person, so I did that. With that, this is pretty much the last feature that I want to cover right now. So seal classes, these were introduced in JDK 17. The whole attempt of giving seal classes was to provide fine-grained inheritance control in Java. And when I say fine-grained inheritance control, it's super important, especially as a library maintainer. It becomes especially important because you kind of want to control uh, like how much of the hierarchy you're exposing or allowing it to extend. Now, prior to JDK 17, every non-final class could be extended by any number of subclasses. Now that allowed developers to just keep on extending and like add their own implementation, so on and so forth. But that also meant that like it made it difficult for library maintainers to make breaking changes, because we never knew that what other extension someone might else have, so on, so on and so forth. So With seal classes in JDK 17, what we do is we get that fine grained control. And how do we get it? We get two new modifiers called as sealed and non-sealed, and the new clause called as permit. The sealed modifier essentially denotes that, like, hey, this particular class can only be extended or implemented, and I should say this particular class or interface can only be extended or implemented by those classes that are permitted to do so. And non-sealed means everything is open, like, on that part of the hierarchy, and any number of classes can implement or extend them. The clause called permits is needs to be supplied along with the sealed clause, so that where you can list out the classes that are allowed to essentially extend or implement it. A few caveats over there. You need the permits clause only if the subclasses are in different files in the same module or even in the same package. Then you need permits, so that you sort of notifying that, like, they may extend the seal class. However, if the seal classes are in the same file as the sealed super, sorry, if the subclasses are in the same file as the sealed superclass, then you don't need the permits clause. And this is something which I actually newly learned while I was preparing for the for the presentation, where I was like, okay, why? Because I like to have, like, my test, like running test, all the code that I've written there is actually running, and it's available in the GitHub repo. And I couldn't understand what I expected and how I was observing the behavior. So then I had to, like, research more, and that's when I figured that out. So with that, let's look at some examples, right? Like I said, seeing is believing. So let's first look at the class diagram. Just imagine that you have this hierarchy where you have an interface called user. It is denoted with, like, dashed lines, because dashed lines in this case are for sealed classes. And it has three implementations: owner, admin, and resident. Owner is a solid line, so that's a final class. Admin is a sealed class, okay, and resident is a non-sealed class. So an admin only permits super admin. So that's why only super admin, you can see, has the extension allowed, whereas the temp admin, even though he wants to be admin, like, the temp admin is not allowed to be to allowed to extend from admin. Like, that's why there's a big red cross there. The resident, on the other hand, it's a non-seal class, so that's why any number of subclasses are allowed to extend it, as you can see here. So let's look at the actual code, how it looks. Essentially, like I said before, you have the user class. It permits the user interface, which permits the three classes, which is owner, admin, and resident. And I just put in a default method out there called as login, so that I could have, like, some test to prove something. So now, in terms of the essentially the hierarchy, let's say you have, as I had shown before, like, you had the owner class, which was final. That's why the solid line. Then you have admin, which is the seal class. That's why the dashed line. And the admin only permits super admin. So remember that. And then resident, which was the dotted line, it's a non-seal class, and it implements user. So from a sealed class perspective, what ends up happening is I can have my super admin, because it's permitted from the sealed class admin to extend it. So essentially, I have my super admin, which extends admin, and this test passes, because if you remember, this login method is coming from the interface. It's a default method coming from user, so this test passes. However, this if I write something like this, where temp admin extends admin, it doesn't even compile, and it does not compile because temp admin does not have the permits clause out here. And that's sort of like, safeguards. You're basically locked the hierarchy over there, and that's pretty cool. For the non-sealed classes, where you have, like, basically opened it up for any number of subclasses, in this case it's resident. You don't need a permits class, because by default non-sealed classes are open. So essentially, you get, like, day guests that can have extends resident. Same thing for overnight guests. So I mean, previous to the sealed classes, Java had, like, a minor bit of control by giving, like, package private, or, like, protected and everything. But with this, it's sort of like, amping up the control that Java gives to, like, control of the hierarchy. Now, within the JDK upgrades, it's not just necessary that only new stuff was added. Some stuff was removed as well. Few of the examples are the Nashon engine, which was completely removed in JDK 15. However, if you still need an engine like that, what they did was they spun off Nashon engine as a separate OpenJDK project. Now you can just add it as a Maven dependency and use it. Our friend CMS GC that was removed in JDK 14, it had a nice and long run, but I think it was time because we also get multiple new GCs that are there. The sort of two more interesting things that happened in especially in JDK 16 and 17 was and 17 more so, where the JDK internals are now strongly encapsulated, and this is going to be one of the sort of challenges that we face when you're upgrading from versions of JDK, and we'll talk about that in just a second. And just for completeness sake, these are the GCs that are available right now, and you can research more. There's a lot of literature on garbage collectors itself, so I'm not going to dive deep in that over here. And just to summarize a few things, there are performance improvements and feature improvements when you upgrade to Java 17. When you upgrade, period. And it's extremely important that you actually consider the JDK upgrade as a part of your tech strategy, or as a part of your product strategy even. If you're still on JDK 8, my suggestion will be to skip JDK 11 altogether and just go directly to JDK 17. Because in my experience, what has happened is from 8 to 9 is sort of a barrier that you have to cross with the modular system. Then if you go from 8 to 9 and then 9 to 11, by the way, 9 is not an LTS release, so you'll go from 8 to 11, and then from 11 to 17 there is a barrier because of the strong encapsulation. Now, I don't expect majority of the developers to be impacted directly for their specific code with the strong encapsulation. I do expect the libraries to be impacted by the strong encapsulation. So what that means is you have to research whether the libraries that you're using are essentially support JDK 17 or not. If they support, which version do they support, and then upgrade it. The latest version of Eclipse Collections 11.1.0 already supports JDK 17. So, if you're using Eclipse Collections, at least from an Eclipse Collections perspective, you should not have an issue. We are a part of the early adopter program, so it sort of helps us stay abreast with the new changes that are coming up, and preemptively make some changes in order to line up the library for a JDK release. JDK 17 is more than a year old already. It was released last year in September of 2021. JDK 19 was already released earlier this month, right? And 21, which will be the next LTS release, will be out in September 2023. So what I'm saying is the JDK train is not waiting. Jump on it, embrace the future. Only when you upgrade, you will get you will unlock all of these cool new features that are super important, and that makes our life as developers pretty nice and pretty exciting. So my tip will be embrace the future and jump on the train and upgrade. And with that, I really appreciate you taking the time and attending the talk. And I'll hand it over to Mala. It was a genuine pleasure. And if you have any questions, I'm happy to answer those.
First of all, thank you, Nikhil. That was a lot of content to consume in an hour. Of course, I'm all for the takeaway slide that you had in the end. We're talking about upgrade with a strategy, because everything has a cost, whether you take an action or whether you don't take an action. And as you rightly mentioned, every upgrade might affect different set of developers. We're talking about developers, maintainers of libraries. Also, if our solutions are deployed on premises or on cloud, because there are a lot of improvements if we talk about porting our applications to running our applications on cloud. So now let me add one question. Tagi has done a wonderful job. He he answered almost all the questions. So we just have one or two questions for you. Taghi leads the IntelliJ IDEA Java team at
Yep.
JetBrains, and he works on all the improvements that we have regarding the Java inspections on the team. So
Yeah, yeah,
there was.
Tagir, I should give like a big thank you to Tagir. And next time, like, we meet in person, I owe you your favorite beverage, Tagir. So let's hope our paths cross soon, and really appreciate you being so actively involved in the talk and in the community as well.
Thanks, Nikhil. So the first question is about upgrading with a strategy, as you mentioned. So there was a question from Faisal mentioned that yes, they are running on Java 8 at present, but they want to upgrade to Java 17, and they're doing that soon. I'm unsure whether they already have a strategy, but is there a checklist somewhere that anyone could refer to, like part one done, part two failed? So that's a no-go. So is there already a checklist that you know of, or do you have one of your own?
So I have not come across one publicly available, but I'm pretty sure, like, individual corporations will have that, like, because essentially what ends up happening is uh, each sort of workplace that you work at has, like, different rules, different regulations, and different requirements, as well as different tools that we use. So a few things that, like, come to mind is, believe it or not, like, Mark Reinhold tweets out, like, right along a particular release that, like, hey, like, all test green on JDK, like, 16 or like 17, and stuff like that. So
Right.
if you look at that, and like we as like library maintainers end up like actually tweeting which version of our software is supported. And then the
Right.
open JDK adoption program also has like a whole list of and I'll ping the link for the adoption, the early adopters program as well, because it has a list of like, it has a nice matrix of which library version is available with or supports which version of Java. And especially with Eclipse collections, we do a pretty nice job, and that is sort of one of our things that we're sticklers about is in our README itself, or in our reference documentation, we have like a nice matrix which shows. And I'm pretty sure few other like well-known projects have that. So long story short, there's a little bit of research that needs to happen over there, and it all depends on which projects you're using and which libraries you're using.
Thank you so much. There was another question about what are you using to present your slides. So
Oh,
I
sure.
don't know whether it's good to have to showcase how IntelliJ IDEA can use or work with AskIDoc, or should we be more happy if you're talking about the inspections? Because you had a lot of slides where you were talking about the language features and how you could convert one if statement to the switch expressions. And IntelliJ IDEA has so many inspections out there, it can actually figure out which if statements could be converted to switch
Yeah.
expressions at the click of a button. And another inspection where you can find out all those accesses. I think the name of the inspection is if convert if to switch, and that's amazing. So everyone who is watching it, if you want to try out all the new features, language features which Nikhil mentioned, use them within IDEA. It has amazing inspections.
Yeah, and I sort of like, inspections, live templates, like this is something which has become like sort of like a part of my bread and butter, like, or rather, like that has become like a muscle memory. Like I don't even now know if like I don't have my like the live templates that I've already set up, like how to like work without those, or like even the IntelliJ inspections, because like you get that squiggly line, or that like
Yes.
orange line, and that's like it becomes like a trigger to your brain, right? Like, hey, something is wrong, let's go fix it. I am using ASCII-Doc. There's a plugin, an IntelliJ plugin already available, and it's pretty cool. Go investigate that. And there is a lot of documentation already about ASCII-Doc as well. So that's the framework that I'm using, and it sort of helps not having to create PowerPoint presentations and make it very manual, because then I just have to focus on writing code.
Right. There's so many topics that I wanted to talk with you about on, but I think we're running out of time. So I'll just take one last question. You talked
Sure.
about some performance test.
Hmm.
There was one question which says, have you made some performance test using Kotlin as well? So probably the person is trying to figure out if they need to switch from Kotlin to Java. But they should already be using JVM.
Yeah. Kotlin is also a JVM based language, but do I have latest performance tests? The answer is no, I do not. I did have a presentation which was called JVM Language Compare with my two friends, Don Rab and Leo Lima, and in there we had done some comparisons as well. But the right answer is latest. I do not have the information, and I don't want to misguide the audience. So.
It's such a shame. Time is running out. So, Nikhil, any closing comments for your session today?
I had a lovely time presenting. This was actually, I was presenting for the first time after a couple of years externally. So thanks a lot, Mala, for giving me the opportunity to sort of resurrect something that I absolutely love and, embrace the future. That's what I'll leave with. Thanks a lot.
Thank you so much, Nikhil. It was a pleasure to have you present with us today. And
Likewise. Yeah.
I'll take you off the stream. Thanks. Bye bye.